Let's try one that's a little more complicated. Okay, so this one's quite a long expression. And you'll notice that we have quite a bit of distributing that we have to do before we do anything. So first of all, I need to distribute this 2 among this parentheses, and I need to distribute this 7 out to all of the terms in that set of parentheses. And then at the end, we're actually going to have to distribute out this -3. So we have quite a bit to do before we actually even start combining like terms. But let's start on the inside first. Usually if you can start on the inside and work your way out, it's a pretty good, this is usually a pretty good method. It works well. So let's start on the inside terms. So we're going to start by distributing out this 2 to each of the terms in that set of parentheses. And then we'll also distribute out the 7 into each of the 3 terms in this set of parentheses. Now don't forget about the -3. It's still on the outside, so we need to make sure that we still put the -3 out there and we still have our brackets. So 2 times x squared will become 2x squared. 2 times -7 will become -14. 7 times positive 12, this will be a positive 84, so 7 times 12x cubed will be 84x cubed. 7 times a negative x will be negative 7x. Again, our rules of multiplying negatives and positives still apply, so a positive times a negative is a negative number. And then a positive 7 times a positive b cubed is a positive 7 plus, excuse me, a positive 7b cubed, so we'll get plus 7b cubed at the end. Now all of this, though, is multiplied by -3. So now I actually have to go through and distribute out the -3. Now here's something you can do first, though. This isn't the case in this problem, but the next step I would do is I would look through here and see if anything has like terms on the inside of the parentheses or the inside of the brackets. Because on the inside, if they do have like terms, you can go ahead and combine them first before you distribute out this number. And what that does, it just keeps you from having to do quite as much arithmetic. Now you don't have to combine them. You could easily just distribute out the -3 first and then combine like terms. It still works out the exact same way. I find it easier to clean up the inside first if you can, and then multiply by the number on the outside. So I look on the inside, I notice that nothing in here is like terms, so I'm kind of stuck. I can't do much cleanup. So my next step is going to be just to multiply out this -3. So in this case, I have 5 terms that it needs to multiply out to, so make sure you get all 5 of them. All right, so -3 times a positive 2x squared will be -6x squared. -3 times a positive 14, sorry, -3 times a -14 will be a positive 42. -3 times a positive 84 is going to give me a negative 252. So this will be negative 252x cubed. -3 times a negative 7x will be a positive 21x, and then -3 times a positive 7b cubed will be negative 21b cubed. I kind of know this is the case because I didn't have any like terms before. I shouldn't have any like terms now, but we'll just double check. Yeah, nothing in here will combine, so this actually ends up being my final answer, even though it's kind of an ugly long term. This is as simplified as I can get this expression. Now, it's possible I could give you an expression that can't simplify at all. So just be careful of that. Don't get frustrated. I might give something like this. So x cubed plus 2x, y squared, z cubed minus 3. In this case, there are no like terms. Nothing has the exact same variable part to it. So this is as far as I can go. This is the simplified expression already. I can't actually do any work for it. Just one more thing I want to mention. I kind of hinted at this before, but as far as distributing a negative sign, We already said that we could think of this as maybe being a -1 on the front, this negative sign, and we can distribute out this -1 to all three of these parts. So -1 times 4 is -4, -1 times x is -x, -1 times -3y would be a +3y. But if you notice this negative sign, by distributing a negative, you'll always just flip the sign of whatever the terms are. So the +4 becomes negative, the +x becomes negative, the -3y becomes positive. This is because anytime you multiply anything by a -1, the only thing it's going to do is change the sign of that number. It's not going to affect the size of the number necessarily, just the sign that it has. So if you want to think about the negative sign doing that, just changing the sign of all of the numbers you can, or if you like to think about just multiplying by -1, you'll get the same result for both of those ways of thinking. So let's take a look at evaluating some algebraic expressions whenever we're given a certain value for our variable, or for, in some cases, multiple variables. This is kind of a staple thing that we'll do a lot in the algebra class. It's kind of one of the basic things that helps us with our problem solving. So the idea here is we have some expression 2 times x cubed minus 3x, and I want to evaluate this expression for a certain value of x. The reason we call x, of course, a variable is because we can make it whatever number we'd like to, but in this case I'm going to make x be a specific number. And doing this evaluations is relatively simple. All we have to do is go through, and every time we see an x in the problem, I'm going to replace it with a 2. So 2x cubed minus 3x evaluated at x equals 2, we're just going to go through and place that x with the 2 everywhere we see it, and then everything else stays the same. So this becomes 2 times 2 cubed minus 3 times 2. 2 times 2 cubed, that would be 2 times 8. 3 times 2 is 6. Again, I can do multiple rules at the same time when I'm doing these simplifications because there's no exponents here, so it won't affect this value. Lastly, I get 2 times 8, which is 16, and we have 16 minus 6, which ends up being 10. So this expression evaluated at x equals 2 is equal to 10. Now I can do this with multiple variables. I don't have to just have one variable in my expression. So something like this, x plus y divided by 2y squared, evaluated when x equals 5 and y equals -3. Again, I'm going to do this the exact same way. Everywhere in my expression that I see an x, I'm just going to replace it with a 5. And then I go back through the expression, everywhere I see a y, I'll just replace it with a -3, and then do the simplification, and whatever number I get is my answer. So we only have one x here, so I'll put a 5 there for that x. This is a y, so plus y would be plus -3. And then 2 times y squared, so that would be 2 times -3 squared. Again, just replacing them exactly as you would imagine. So now I just need to simplify my expression. So 5 plus a -3, that's the same thing as 5 minus 3. So this will become 2. -3 squared, now be careful, this is -3 times -3, so that becomes a positive 9 because it's negative times a negative. So this will become 2 times 9 in the denominator. So I'll end up with 2 over 18, or just 1 over 9 for my answer. We'll try one more. So the absolute value of 4x cubed plus 8y minus 3 evaluated when x equals -3 and y equals 1/2. Again, I'll just go through, and every time I see an x, I'll replace that with a -3. And then every time I see a y, I'll replace that with a 1/2. There's nothing here, so this just remains -3. Don't forget your absolute value signs. If you do, then you could possibly get the answer wrong at the end. You might get a negative version of something that should be positive. So -3 cubed, this is a negative times a negative times a negative. If you think about cubing a negative, it will always be negative because this number times this number will be a positive, and then the positive times the negative will make it a negative. Or if you want to think about a negative number raised to an odd power will always be a negative number. A negative number raised to an even power will always be a positive number. If you raise a positive number to any power, it's always positive. So the only ones you have to worry about are the negatives. But a negative to an odd power is negative. A negative to an even power, like 2, 4, 6, or 8, will always be positive. So in this case, 3 cubed is 27, but it's negative, and it's to an odd power, so it'll be -27. 8 times 1/2 is 4. And sure enough, you probably recognize this from one of the other problems in the book, or one of the other problems in the notes that we've done before. This is -108. 4 minus 3 is 1, and so we get -108 plus 1. So absolute value of -107. So this will be +107 will be our answer. The nice thing about these is no matter how complicated I make this expression, if you can just plug in the numbers and do the arithmetic, then you're set and you can do all these types of problems.